Using data to create insights is incredibly beneficial to society, from being able to forecast sales for a business to predicting the weather. However, the key challenge that data analysts, data scientists, data engineers, and you'll be facing is cleaning the data that you'll create these insights from. Hey folks, I'm Trent. I've been a professional data engineer for 5 years now, and in this video, I wanted to take you through how I clean data using Pandas. I'll take you through several techniques that I've used, and at the end of the video, I want to discuss a key principle in data cleaning that helped me deliver massive amounts of value to my clients and save me hours of work. All right, let's get started. I'll be focusing on common problems that I've seen over my career, those being things like data duplication, missing data, poor data formatting, and poor data standardization. I've just jumped over to my editor over here, and I'm going to take you through the data that we'll be using for this. But just as a note, the first thing that I've done over here is imported the packages I'll be using, those being Pandas, Matplotlib, and NumPy. I'm also just setting some options over here to make things a little easier to read in this Jupyter notebook. All right, so let's run that and import all of the needed modules. And to kick things off, let's take a look at the data itself. So I've got the data stored in a folder over here called data and in a file called data-to-be-cleaned.csv. I'll share this data on my GitHub profile if you want to follow along. Looking at this data, we can see we've got a set of transactional data. This represents different clients sending money to beneficiaries. We've captured the client name, the beneficiary name, an amount of money being sent, the transaction date time that this occurred, and a client tier. We can also see that we've got a transaction ID over here to represent each transaction. Now, just skimming through this set of transactions, we can see a couple of problems. So the first thing to note is in the client column over here, there are some funny characters hanging around on the client names. For example, Frodo Baggins has got angle brackets around the name over here. You can see a bunch of dots appearing. Harry Potter has got a star in between the first name and last name, and Walter White has some dashes around their name. Then further, we can also see that some names are capitalized, whereas others are not. We've got missing values here in the client name, and we can see a couple of missing values in the amount column as well as the client tiering column. So these are the issues that we are going to have to deal with in the data. On top of these issues, we can also note that there are a few transactions that look like duplicates. For example, this transaction over here from Tony Stark to Bruce Banner looks exactly the same. Everything is exactly the same except for the transaction ID. For example, the transaction that's being recorded is the exact same amount at the exact same time. So we could assume that there's also duplication in the sets of data. We can see that happening here as well between Sherlock Holmes and John Watson. These two transactions look identical in everything except for the transaction ID. So we've got some duplication as well. To just get an overview of how much missing data we have, I'm just going to use the df.info method over here to take a look at how much data we have and how many non-null values we have for each column. So we can see that client is missing a couple of values because we have 40 entries in total. Client only has 38 that are not null. Client tier only has 37, and amount USD has 38 non-null values as well. This just gives us a high-level overview, again, of how many missing values we have. When we're faced with the task of data cleaning, generally, we either want to drop the erroneous data or the unclean data, or impute and infer what the data should actually look like. In either case, it's important to note that you are going to introduce a certain amount of error in the data. So it's important to keep track of what you're doing and how much error you're potentially adding to the data set by doing this type of inference or dropping of data. All right, with that out of the way, let's start actually cleaning this data set. The first thing I want to deal with is dropping data. So as I said, there's two different techniques, broadly speaking, is either we're going to get rid of data or we're going to infer data. So the simplest one is, of course, to get rid of data. In this case, the data that I want to get rid of is actually the records for which we have a missing value for the client, right? So for example, transaction 15 over here, we don't know who the client is sending money to Luke Skywalker. So I'm going to drop this record. And the reason why I'm going to approach it this way is because it's really hard to infer who sent this money to Luke Skywalker. Perhaps if our data set was bigger, we could infer that by looking at all the different transactions that Luke Skywalker is receiving, and then infer that it might be the most common sender of money to them. But in this case, we've only got 40 records, and I'm going to say that actually I think it is logical for us to get rid of these records simply because we don't know. And by assuming the sender of a transaction, we're introducing a whole bunch of error. I'm going to stick with dropping this data or dropping this record. I think there is another record over here that also has a null client, and that is this record, whoever's sending money to Tyrion Lannister. Let's go ahead and drop those records. First thing I'm going to do is create a new data frame called cleaned df, which is going to be a copy of my original df or my original data frame. The reason I'm creating a copy is so that I have a copy of our original data or keep track of our original data, and then have a completely new data frame that we're going to use for our cleaned data set. In our clean df, I want to take the cleaned data frame or clean df and specify that I'm going to drop NA or drop null values. So using this drop NA method, I am then going to specify a subset. The subset I'm going to specify is the columns for which I want to do this method or drop NA values or drop null values. Specifically, I want to drop null values in client, right? And then I'm going to specify in place equals true. So this keyword of in place just means that I'm going to do this drop on this data frame in a single line over here. I don't have to reassign my data frame. Instead, it's just going to operate on this data frame directly. So after doing that, let's go ahead and print our result and see what we get. Alrighty, and we can see that the null values have been dropped. So if I scroll down, transaction 15 is no longer there. And further down, we can see that transaction 27 is no longer there either. So we have successfully gotten rid of our missing data in the client column. Great. The next problem that I want to deal with is getting rid of these potential duplicate records over here. So for example, transactions 3 and 4 over here, I'm going to assume that these are duplicate records and go ahead and keep only one of them. To do that, I'm going to specify cleaned df and use the .drop duplicates method over here and simply run this. Well, first I'm going to specify that I want to do this in place again, set in place to true. And then let's take a look at cleaned df. Alrighty, so that didn't work, right? Because we still have our duplicate records here. The reason this didn't work is because the transaction ID is different for these two separate records over here. So what I need to do in my drop duplicates is specify a subset once again. And in this case, I'm going to specify the subset of all the columns except for transaction ID. So let me go ahead and do that. Alrighty, I've specified the subset of columns, all the columns except for transaction ID over here. So client beneficiary amount, transaction date time, and client tier as my subset for which I want to drop duplicate rows. Let's go ahead and run that. And this time our result is as expected. We've gotten rid of that duplicate record. The other one was between Sherlock Holmes and John Watson. We can see we've only got one record left over here, which is exactly what we wanted. Something interesting to note about the drop duplicates method, though, is there is a keyword that I'm not demonstrating here, but I still think is pretty interesting, and that is the keep keyword. Now, what keep lets you do is specify whether or not you want to keep the duplicate records or get rid of them outright. So the keep keyword can be set to first, which it is set by default, meaning that I want to keep the first instance of a duplicate. I can also set it to last if I want to keep the last instance of a duplicate, and I can set this to false if I want to get rid of all my duplicate records outright. Again, I'm not really using this in this case, and I'm happy with keeping it as the default value of first, but just interesting to note and has been pretty useful in the past. So now we've gotten rid of our duplicate records. The next problem that I want to deal with in our dataset is the formatting issues we can see, or the poor data formatting in the client and beneficiary columns. So what we want to do first is get rid of all these weird characters that are appearing in the client column. To do this, I first need to establish what weird characters are appearing. Now, this data set is only 40 records long, so we could just eyeball it, but in the real world, you're going to be dealing with much bigger data sets, and if you have 100,000 records, going through each one and figuring out what weird characters appear is not going to be practical. So let's take a more general approach. And to do this, I'm going to be using regex. And if you're unfamiliar with regex, it can get quite complicated, but really all you need to know is that it is a pattern matching syntax for text data or for string data. I'm not going to be doing anything too fancy. Regex can get quite deep. The theory can get quite deep. I'm just going to be using some basic regex to match some patterns in our string data over here. Let's take a look at that. So let us grab our cleaned data frame again. And in the clean data frame, the column of interest for me is the client column. First thing I'm going to do is specify str for string, the string methods or use string operators on this column. And then I'm going to do a replace, string.replace on this column. And what I'm going to replace is all of the alphanumeric characters with nothing. So I'm basically going to subtract out all of the alphanumeric characters. To subtract all the alphanumeric characters out of the client column, I'm going to specify a regex pattern like this. The first thing I want to subtract are all lowercase alphabetical letters, or the lowercase alphabet, should I say. So A through Z. Then I'm going to specify the capital A through to capital Z as well. Then I want to specify numbers, so 0 through 9, as well as the space character as well. So I want to subtract all of these characters that I consider valid out and see what is left. What I want to do is also specify over here that I'm going to be replacing this with an empty string and the fact that I'm using regex, so setting regex to true. Let's take a look at what the result of this is. You can see that I get a column that has all of the names subtracted out, and what I'm left with are just these strange characters. Now I want to get a unique list of all these strange characters, and to do that I'm just going to add on over here a .unique to give me a list of all the weird characters that have appeared in this column. Alrighty, so that looks a lot better. You can see the first thing over here is the blank character. I'm not too worried about that. But the ones of interest are the angle brackets, the dot, the star over here, and the dashes. So this has given me a list of characters to search for and to get rid of. So using this information, the first thing I'm going to do is take clean df. Again, I'm going to be working with client, specify string again for the string operators. And I'm going to use this method over here called strip. What strip does is it focuses on cleaning the left-hand side and right-hand side characters of your string. So for example, it will focus on these types of characters over here. The other issue that I've seen that's pretty common is extra spaces being put on the sides of different text data. So strip can really help you out there because you can also strip out or get rid of extra spaces on the left-hand side and right-hand side of your text data. So strip focuses only on those characters. It's not going to affect the middle of our text. So for example, we won't expect it to clean this text over here because the star in Harry Star Potter is in between the text. Strip will only work on the outside of this text. To use strip, what we can do is specify a set of characters as a single string, which is a little weird, but it's all right, we can we'll work with it. But we're going to specify the weird characters as a single string. So I'm going to specify the angle brackets, the full stop, the star, and the dash, as well as these space characters. So I'm just going to hit space over here as well and specify space to be trimmed out as well, or stripped out as well. All right, so let's run this and see what we get. All right, so our resultant column over here looks pretty good. We can see that Frodo Baggins no longer has the angle brackets, Jon Snow no longer has the dot, and Walter White no longer has the dashes on their name. To finish things off, what we want to do is insert this resultant column as our client column in the cleaned data frame. So to do that, all I'm going to do is specify clean df again, specify the column client, and use the assignment operator to assign the resulting cleaned client column as my client column in the cleaned data frame. Sorry, that came out really confusing, but you'll see what I mean. So if I print this out, we can see that now our client column is the cleaned column. The issue that remains is Harry Star Potter. To deal with that, I'm going to use, again, very similar syntax, specify the client column. We're going to assign again this time, specify client. But in this case, I'm going to use the replace operator, or .string.replace operator, to replace the star character, not with an empty string, but with a space, right? Because I know that when the star appears over here, and I've already done the strip, when these weird characters appear, I don't want this to be Harry Potter in one word. I want it to be Harry space Potter. All right, so let's run that. And we can see we got the result we wanted. Awesome. So we've dealt with the data formatting issues. The next thing to deal with is data standardization. Over here, we have Darth Vader in all caps, whereas no other names follow that standard, right? Similarly, in the beneficiary column, we have Gus Fring, who is in all caps, but all of the other names do not follow that standard. So what we want to do is standardize the columns. To do that, I'm just going to arbitrarily pick the standard of making all of my elements or all of the names uppercase. So to achieve that, I'm going to take our cleaned data frame again, take our client column, or select our client column, use string, the string methods again, and I'm going to specify upper in this case. So just to show you the result of this, you can see that all of the names are now in uppercase, consistently in uppercase, right? So I'm going to steal this over here and go ahead and assign this. And then just take this again, but this time I want to do this for beneficiary as well. So let's go ahead and select client and replace that with beneficiary. All right, and then to see the result of what we've done, let's take a look at cleaned df again. So we've got client and beneficiary. Now all the names are in uppercase. You could do something similar using the .lower method as well if you prefer lowercase. This is just personal preference. The main point is that all of the names are now following the same standard. They are all in uppercase, and this just makes analysis easier downstream so that we have a common standard for the names. Alrighty, so we've cleaned up our client and beneficiary data and happy with the outputs thus far. Now I want to move on to cleaning our numeric data, the amount USD. In this case, we've got a couple of missing values. So that looks like the only issue. Yeah, that is the only issue. And in this case, I'm going to impute or infer what the value should be, what the missing value should be. A common strategy for numeric data is to replace the missing values with some form of statistic like the mean or median. These are simplistic methods to infer what the data should be. We could also get super fancy and use a machine learning algorithm, but I'm going to keep things simple here. And generally speaking, the mean or median is usually the way to go. But to make things a bit more clear, to illustrate the difference between the mean and median to you, I'm going to go ahead and visualize the distribution of our amount USD data. So I'm going to use matplotlib to plot out the distribution. Alrighty, so the code that I've added here, just to run through it super quickly, I've specified a variable here, AX for axis, as the plot of clean data frame, the column amount USD, dot plot, kind equals hist for histogram, so the plot of a histogram, with 10 bins, so splitting our data up into 10 different bins, and the color set as sky blue, and then the edge color as black, just to make things easier to see. I've just set the Y label and X label so that the graph is a little easier to read, and I've specified a legend over here on our plot. And then I'm just showing the plot using matplotlib. So let's go ahead and run that. And we can see the distribution of our amount USD data. Something to note over here is that the distribution is quite skewed, right? It's quite skewed to the left. And that means that there are more lower values or values around this range of about, like, let's say 50 to like 120 something, I'd say, then there are values above that range. Or at least that's what it looks like, right? That's what the data distribution looks like. Now, to illustrate the difference between the mean and median so that we can make an informed decision about what we're going to use to infer the missing values, I want to plot the mean and median on this graph. So to do that, I'm first going to calculate those two values. So let's say mean value as a variable equals our cleaned data frame, specifically the amount USD column, dot mean, and that gives us the average, right? So simply the sum of the amount USD divided by the count or number of records that we have, right? That is the mean. Similarly, let's specify the median value is equal to cleandf, select the amount USD, dot median. And in this case, right, the median is the 50th percentile or middlemost value, right? The middle value in all of our records. We've specified those two values as variables. I'm just going to add some code to visualize those on this graph. So the code that I've specified over here is this AXV line for axis vertical line, right, that I'm going to use to plot two vertical lines at the points of our mean value and our median value. So in this top line over here, I'm specifying the mean value. I want to use dark blue as the color. I'm going to make it a dashed line, make the width 2 so that it's clear to see, and then label it with the actual mean value so that we can see that pop up in our legend. I've done something similar for the median value. Let's go ahead and rerun this to see the two different values. All right, so we can see the mean is 146.41, whereas the median is 122.75. Plotted over here, we can see that the mean is more toward the center, but the thing is it looks further away from the majority of our data as compared to the median, right? So the median value is in and amongst more of the data, meaning that it's probably closer to the majority of our data. Well, not that it's probably closer, it is closer to the majority of our data. The thing is, when we impute data, we want to minimize the amount of error we introduce, and so we need some way of measuring that error. To illustrate this point, I'm going to take a look at the difference between the values that we have and these two different statistics over here. To get an idea of how much error we'd introduce by replacing the missing values with these statistics, let's go ahead and look at first the difference, so mp.abs, the absolute difference between the mean value and the data we have, right? So let's go ahead and take np.abs for absolute between cleaned df amount USD minus the mean value over here. So if I run this, I'm going to get a list of differences over here, right? So the difference between the actual amount and the mean value. Now I want some way of aggregating this, so I'm going to actually take the average, right? So I'm taking an average of the difference between the values and their average. A little confusing, but it's basically the average error that I'm looking at, or the average delta, right, between the actual values and the mean value. So let's go ahead and specify mp.mean over here, open brackets, close brackets, and we get a value of 59. What this means is that on average, the mean deviates from the actual value by about $59. Let's do something similar for the median. So let's add another line of code here. And I actually just want to subtract the median value. When we run that, we can see that the average deviation between the median and the values in amount USD is $55. So the median introduces less errors than the mean. Now, this is typically true of data that's skewed like this. In the case of a distribution like a Gaussian distribution, if you have a perfect Gaussian distribution, your mean and median are going to be the same value, right? But in this case, for skew data, the median is usually the way to go, but it's nice to have a technique that can actually show or approximate the amount of error that you're introducing by doing an inference over here. All right, so I'm going to go ahead and use the median. To replace my null values with the median, what I'm going to do is specify cleaned df dot fill NA, so fill null values. And then in fill NA, I'm going to specify a dictionary. The key of the dictionary is amount USD, or the column that I'm referring to. And the value in this dictionary is going to be the value that I'm going to fill with. Again, I'm going to specify in place equals true in this case. So to do it in place, and then just print out our data frame to take a look at the result. So running this, we can see that we get the median values getting put in place over here. So just to remind myself, yes, that is the median value, 122.75. So in this case, our null values have been replaced with the median. All right, so we've dealt with our numerical data as well, and we've done an inference on the missing numeric data. The last thing we need to do to clean up this data set is infer the values for the client tier. There are a couple of missing values in here, and we're going to use a somewhat similar technique to what we used in the amount USD case. Now, the thing is, the client tier data is actually categorical data, right? We can't take the average of this, nor can we find the median, but we can find a statistic called the mode. And the modal value is simply the most frequently occurring value in the categories. So in this case, if we say that something like the tier gold occurs most frequently, that would be the modal value, and we would use that to replace our missing values. Just to illustrate this, I'm going to go ahead and visualize the distribution of our category data. Okay, so to look at the distribution of the category data, I'm creating a variable here called tier counts, which is equal to clean data frame, the client tier column, or selecting the client tier column, and getting value counts. Actually, to illustrate this, let me first comment this out for a second and print out tier counts just to show you what that looks like. All this is the different tiers, gold, silver, platinum, and bronze, and their respective counts. So two columns, one is the client tier, and then the other is the count or the frequency at which that tier occurs. Alrighty, so just to take you through the plotting code, I'm going to take tier counts.plot. This time I'm going to plot a bar chart in red with the edge color being black. I've set a couple of labels just on the X and Y axes, as well as a title. Over here, I'm just rotating the labels on the X axis so it's a bit easier to read, and then showing the plot. So let's go ahead and run this. We can see that the most frequently occurring tier is in fact gold, followed by silver, platinum, and then bronze. The thing is that gold is not dominant by many. Actually, if we look again at the tier counts, so let's go ahead and grab the tier counts, we can see that gold occurs 13 times, but all the tiers that are not gold, so silver, platinum, and bronze, account for 9 plus 6 plus 5, about 20 records versus 13, which means if I were to replace all the values with the gold tier, the most frequently occurring tier, I would be wrong about 20 out of, is that 33 times? And looking at that, that means I'd be wrong about 60% of the time, which is quite a lot of error, right? So it's important to note this. I'm going to still use the modal value. So I'm going to use the value of gold over here to replace my null values. But it's important to note that we are introducing quite a significant amount of error on the records for which we are inferring this data. So the first thing I'm going to do is find the mode. So let's call it client tier mode. equals cleaned df client tier dot mode. Let's just print that out to see what we get. So you'll notice that the client tier mode is actually an array, or actually a series of values, right? Over here, a Pandas series of values. Really, we just want the string gold. So to do that, I'm going to index the series and select the 0th item, which happens to be just gold over here, right? And get my string gold. Funnily enough, it looks like there is a space on this value over here, which means actually I need to clean my data, right? So clean df client tier equals cleaned df client tier dot string dot strip, right? If I run that and then rerun this, there we go, got rid of those extra annoying spaces. So yeah, again, a bonus cleaning step that we have over here. Alrighty, so we've gotten our modal value, and to replace the missing values in the client tier column, I'm going to follow a very similar method to what I did for the amount USD column. So let's do that. So clean df dot fill NA. Again, I'm going to specify a dictionary where the key is client tier, because that's the column we're interested in, and the value is the client tier mode over there. I'm then going to specify in place equals true, right? And let's print out our data frame to take a look at the result. And we can see we've replaced the null values with the modal value. So we've gone through several methods to clean a dataset, including dealing with bad data formatting, bad data standardization, and inferring missing values. Now what I wanted to discuss was one of the key principles of data cleaning that has really helped me out in my career. The essential principle of data cleaning that I'm referring to is to remember the context of the data generating process itself. This context should always inform how you clean data. Let me make things a little more practical with an example. So I've created some dummy data over here that's very similar to a set of data that I was working on for a client of mine. Now, in this data set, we have got a date and a currency conversion rate. So I was working on converting Forex transactions to a base currency for my client. What I needed was currency conversion rates. Much like over here, I have the euro and US dollar rate, and I needed these rates for all the transactions that I was seeing to convert them to a base currency like US dollars. What I found is that the dataset would periodically be missing data for the conversion rates. Now, my first instinct was to go ahead and try and predict the conversion rates using some advanced machine learning model to really infer what the price of the currency conversion would be. Now, predicting the price of currencies is a business in and of itself, and if I pursued that method, maybe I would be a lot more wealthy. But it turns out that the missing values would occur on weekends, right? The markets would close, and so I wouldn't get any data on the weekends. And the right method to use, the accepted practice to use for currency conversion data, or these FX rates, was to simply feed forward the Friday rates on a Saturday and Sunday. Now, this is way simpler than trying to predict the price of euro to USD for a particular day, right? So to do that, the simple method that I needed to use was taking our data. So in this case, I've got my ForexDF, specifying the euro to USD conversion rate equals ForexDF, again, the specific column, and use fffill for forward fill the data. And if I print out the result, you can see that the Friday rate is being carried over for the Saturday and Sunday. This saved me a ton of hours of work. So always remember, use context to inform how you clean your data. It will save you a lot of time and energy. To make this practical, if you're working for a client Talk to the subject matter experts on the data if they are available to you. Do some research on how the data is generated. Something that I've always found helpful is to draw out a process diagram of how the data is being generated, or just the process that is creating the data. For example, drawing out how does a transaction flow. For example, our transactions data here, where does a client start, or where does the client data start? Which system does it come from, and which system does it end up in? If we're integrating multiple systems, this is super useful to note because we can detect which system, or pinpoint which system is causing the issue, or causing these specific issues that we're seeing. So we've discussed the importance of data cleanliness. We went through some powerful techniques to improve data quality and clean up our data for analysis, and touched on the key principle of data cleaning that I really like, which is to understand the context of the data before you go ahead and clean it. What are some data cleaning techniques that you've used? I'd love to hear about them in the comments below. I'm working on a video dealing with some more advanced data cleaning techniques, and I'll link to that once it's ready. But in the meantime, now that you know how to clean data in Pandas, how do you make your Pandas application super efficient? You can check out my video on improving Pandas efficiency up here. And if you found these techniques in this video helpful, please consider giving it a like and subscribing to the channel for more info on data analysis, data engineering, and data science. Thanks so much for watching, and I'll see you soon.